Alright, welcome to this video. And in this video, I will be doing another coding challenge on codewars.com. So, the name of this coding challenge is Find the Parity Outlier. Alright, the instructions are you are given an array which will have the length of at least 3 but could be very large, containing integers. The array is either entirely comprised of odd integers or entirely comprised of even integers, except for a single integer n. Write a method that takes the array as an argument and returns the outlier n. So for the examples, they have this array here, and all of the numbers are odd. No, all of the numbers are even except for this 11, which is an odd number, and this is the number we're looking for. So you should return this, the only odd number that's in there. And here, all the numbers are odd, and this 160 is the only even number, so you want to return the 160. All right, so let's get into it. All right, so we're going to start off. I'm just going to erase that for right now. The way I'm going to handle this is I'm going to, because the easiest way and most straightforward way is just to get the integer, get the array and loop through and get the, just find it. You know, you determine what you're looking for. Are we looking for a odd or even number, and then just loop through and find it. Since the array is not going to be sorted, the searching algorithms are you're either going to just have to go sequentially, or you're going to have to sort the array first. I think I don't want to do any sorting. I'm just going to go straight for the searching. But the way I'm going to do the searching is I'm going to use multi-threading. I'm going to separate the array into different threads and search the array that way. So split the array into like separate parts, and then search each part separately and concurrently, so we can find it faster. And I'll just return it once it's found, and stop the other threads. So the other threads will be aware if the number has been found. All right, so the way we're going to handle this is we're just going to go through and handle each situation one by one. And we'll end off with just our regular searching logic. So before we even do our searching, we have to do some things like finding out which type we're looking for. Are we looking for an odd number or an even number? And we need to check if the list, because according to these instructions here, the length has to be at least 3. So I don't know if we're supposed to check for this or if that's just a given. So we're going to add a check for it. Simple, quick check. Matter of fact, let's go ahead and do that first. If the integers.length is less than 3, then we'll just return a -1 or something. I don't know what they want. I'm going to return -1. Alright, so now that we're in here, we're going to need to establish some of the fields we're going to need. I know off the back I'm going to want to have the thread pool size. So I'm going to go in pool size. I'm going to set that. I'm going to set it to 3 since there's 3 numbers. At the least, we'll just split it. Give it 3 pools, and we'll split it into thirds or whatever, or something. We'll figure it out. Just make a chunk. All right, and then let's go ahead and do that. Actually, let's go ahead and set up the chunks. So chunk is going to be the integers.length divided by 3. All right, and then from here, we also need to set up our outlier, the actual number that we're going to be returning, our return integer. I'm going to be using an atomic integer because I want our integer to be thread safe. And I'm just going to call it outlier. And also we need an initial value. So I was thinking about using -1, but I think they can use negative numbers. So I'm just gonna use integer max value. Hopefully none of the arrays have the integer max value as a answer or something, because we're going to use that initial value is going to be what we use for certain checks. So hopefully that is not going to be included in any of the examples. It probably is, though. They're probably going to throw it in as an edge case, but we'll see. Next, I'm going to set up the check to see which type we're looking for, if we're going to be looking for an even or an odd number. So I'm going to call this looking for odd, and it's going to be equal to, we're going to get the first index out of the array and check to see if it's even or odd. Now the reason I'm doing this is because I think the easiest way to check if we're looking for an even or an odd number is by just taking the first two indexes from the array and checking to see if they're both even or if they're both odd. That's the easiest way, because if they're both even, then we're looking for an odd number. If they're both odd, then we're looking for an even number. And if they're different, then we already found our outlier, because one of those is the outlier. If one's even and one's odd, that means that one of those two are the outlier. And then all we'll have to do is get the third index out of the array and see what it is. And then whatever the third index is, we know that the outlier is whatever the opposite was. So if the first index is even and the second index is odd, and then the third index is odd, then we know the first index is the correct outlier, because the second are both odd. You see what I'm saying? So we'll be able to determine that from there. So that way we won't even have to do any searching logic for our for that run, because we'll find it immediately. But otherwise, it's just to determine if the number we're looking for is even or odd. So this first variable is going to be looking for odd. So this is going to tell us if we're looking for an odd number. So if it's true, then we're looking for an odd number. If it's false, then we're looking for an even number. So yeah, so here, if it's even, then this will return true. And if it's odd, then this will return false. So we'll also do this for the second number. We'll also do this for the second number in the array. Sorry, I was trying to type and think at the same time. So I'm going to call this one comparator, because this is the one we're comparing it with. So this will be the first index in this array. And we will do the same modulus operation. And so now we need to check if these two are not the same, because if they're not the same, then this is where we need to make sure that we check that third number and get which one is the actual outlier. So this is a special case. So we're going to check if looking for odd is not equal to the comparator. Then we have found our outlier. We just need to figure out which one is the outlier. So now I'm going to call this one comparator 2. This will be the third letter. The third index. So integer. And this will be 2. And we'll do the same modulus operation. So now we know if this is even or odd. And then I will set I'm just going to call this result, because this result is going to be our actual outlier. So we'll do comparator equals comparator 2. So if these two are the same, then we're going to set this to the integers array 0. So this is going to get us the first index, because if both of these are the same, then we want the other index. But if these are not the same, then we want the comparator's index. So here we'll do integers 1. All right, and then we need to set our outlier. So for the atomic integer, they have the set value, and this is what we'll do. We'll set this outlier to the result. All right, so that handles. So now after we've done this logic, we'll know what we're looking for. So if we're looking for odd, then this will come back true. If we're looking for even, then this will come back false, which means that looking for odd is exactly what it's saying. So whenever we use this looking for odd, then that means, are we looking for odd? All right. So let's go ahead down here, and now we can get into our actual threading and our search logic here. So in order to do this, the first thing we need to do before we even get into that, we need to check to see if the outlier was set. If the outlier was set from this logic up here above, then we don't even need to run anything else. We can just skip over all this. So first we need to check if this set. If this is not equal to the integer.max value, the reason we're checking if it's that because this is the initial value that we set. So if it's not that initial value, that means it has been changed. And if it's been changed, then we can just go ahead and return the outlier. So let's go under that if statement. Go ahead and return our outlier. All right. So now inside of this if statement, this is where all of our threading logic and stuff will go. So I will be using the Executor Service, the Java util Executor Service. This will handle all of our threading. So all of our threads and stuff will be handled by this Executor Service. All right, so if you're not familiar with the Executor Service, then that's really all it's going to be doing. We're just going to be using it to handle our multi-threading and stuff. So the way I want to set this up is I'm going to have the list get separated into sublists, and then we're going to search through the sublists all at one time using this Executor Service. So I'm going to define the logic for the searching, and then I'm going to separate the lists and put them each into their own thread, and then execute all of the threads at the same time. So I'm going to be using a class called callable. So I'm going to make a set of these callable classes, and this class is basically, just think of it as a thread. It's going to be a thread. So inside of this thread, I'm going to, define the logic, and I'm going to use these callables with this executor service. So we're going to run those threads all at the same time. So I'm going to create 3 different threads because we're separating by 3 here for our chunks. So I'm going to create 3 different threads and run it that way. Now I'm going to go ahead and create a loop to loop through these 3 different threads so I can create their logic for each thread. All right, so inside of this loop we're going to go ahead and get our sublist. So we're going to take the big array and separate it into sublists. It's going to be 3 different sublists. So integer, we'll call it int list, And I'm going to take the array and convert it into a list, because I want the list to, I need the list to make the sub list, because it's a lot easier to use a list and get a sub list out of it than to actually make sub arrays out of the original array. So I'm gonna make the sub list out of this large list. So int list sub list. All right, so for the sub list, we're going to need to have a starting point and an ending point for the sub list. So the sub list is going to be split into 3. So we're going to want to start from, okay, so for the first one, we're going to want to start at 0, and then want to go up to whatever the third of the list is. And then for the second one, we're going to want to start at where the third of the list is and go up to 2/3 of the list. And then we're going to start at the 2/3 and go up to the ending of the list. So the way we're going to do this is by having a starting point. Because remember, I'm in a loop, so I'm going to have to set this up dynamically. So we're going to have a starting point, and then we're going to go from starting point to starting point plus the chunk size, which we have established up there. So the only thing we need to do now is actually establish this starting point. So I'm going to actually just go up here where we did this chunk and actually put the starting point up here as well. So it's going to be integer starting point, and we're going to set it to 0 because we want to start off at 0 initially. So now once we do this, we have our starting point. And so now we want to increment our starting point after every run. So before we start our next go, we're going to increment the starting point by the chunk size. All right, so once we get that, we can go ahead and create our callable that we're going to put into this set here. So I'm going to establish a new callable. I'm just going to call it callable. And I'm going to use the lambda expression from Java 8 to go ahead and create this. Instead of creating an anonymous class, just go ahead and do this. Now, once we're in here, this is where all of our logic for our searching is going to go. So I'm going to need to loop through that sub list. So I'm going to loop through this sub list. And then while we're going, we need to make sure that we check to see if the outlier has been set by another thread. So we do if outlier dot get is not equal to integer dot max value, then we need to break. Because if it doesn't equal integer dot max value, then that means that it has been set by another thread. So there's no reason for us to continue because we found the outlier. So this will break us from here, and it'll stop this callable from running. That way we're not doing unnecessary iterations through this loop. So next we want to check if we're looking for an odd number. So if we're looking for an odd number, then we want to check to see if this number is odd. So we go through here, we're going to say, is this number, so see we're going looping through here. So we're checking to see if this number is odd. So we're going to go to does not equal 0. So this is checking if it's odd. So if the modulus does not return 0, then we need to set our outlier to this number because this number is the number we're looking for. This is our outlier. And then we also want to break from the loop so we don't keep running, because we're done. We found what we're looking for. Now we also need to check to see if this is an even number. So if we're not looking for an odd number, we're looking for an even number, then we need to do this exact same thing. All right. And this time we're going to set that to equal. So there we go. So now we're looking for an even number. If the number is even, then set the outlier. All right. So starting point. And then the last thing we need to do is actually add this callable to our callables set here. So callables.add callable. All right, so now we're putting it into this callable set. And from here, we are pretty much done. This is all the logic that needs to be done. And once we find it, we're good to go. Set it there, and then we can return it. But there's one other thing we need to do. And this is just for the threads. So before we leave this if statement, we need to stop this executor service. So, because it won't stop just automatically. So we're going to do executor service dot shutdown, and then executor service dot await termination. Then I'm going to set it for a 5-second timeout. All right. And there's one other thing, a major thing that I forgot. This executor service actually needs to invoke these callables. So we need to do that here as well. So executor service. Make sure you do this outside of this loop though. Don't do this inside of the loop. All of this needs to go outside of that loop. So in executor service dot invoke all, and then pass in those callables. All right. So this line here will execute all 3 of the callables that we create here. So if you want to make more, then you need to increase the pool size. If you increase your pool size, then it'll create more chunks. Also, it'll create more threads as well. So it's going to have 1 thread per chunk. And that will do that. So this invokes them, actually runs the methods that we created here. It'll actually run this. And it'll run through the sublist and find the number. This will shut down the executor service, and this just waits for it to shut down. So it'll actually, it won't just cut off. And other than, I think we need to surround this executor service with a try catch, because this does throw an exception. So we're gonna do that. And it throws an interrupted exception. Catch it, and I'll just print stack trace. All right, and let's get the indentation right here. All right, so this should work. Yep, this should work. And then we're turning our outlier. So I'm going to run over this code one more time before I actually test it out, see if it's working. And so we have this atomic integer. This is what's going to be what we're returning. We got our pool size. This is how many in our chunk size. So this is how many threads we're going to have. This is how many chunks we're going to have. I mean, this is not the chunk. This is the chunk size. My mistake. This is the chunk size. This is how many threads we're going to have. So it's going to be 1 chunk per thread, according to that's the way I've set it up here. You can configure this to be however you want it. Our starting point is going to be 0. That's used for our sublisting here. This logic here is how we check to see what we're looking for. Are we looking for an odd and even number? And if the correct outlier is within the first two indexes, we'll find it immediately and just skip over all this extra logic down here. So here we're checking to see if the outlier has been set by this logic. And if it hasn't, then we're going to go through, create a new executor service. This is what's going to run our threads. We're going to set the thread size to pool size, and then we're going to create a callables set that will hold all of our callables. So it's going to basically hold all of our threads that we want to run. And then we establish our threads in this for loop. We're going to define our threads, and our threads are just sublists of our original array, so we can concurrently check them all at the same time. Then we actually create the logic here. This is where we're checking if the number that we're on is the actual outlier. So all these will all be running at the same time. And then we come down here, we're incrementing our starting point so we can set our sublists correctly. Then we're adding our callable to that callable set. And here we're invoking all of our callables, shutting down the executor service, and then we're returning our outlier. So this should work. We're gonna check it out and see. Let's go ahead and hit the test. Oh, we have an issue. Oh, I forgot. We have to add all of our imports manually here. Here are all the imports I needed. I went through, found them. Here they go. And now let's try to run this again. And we still have an error. Oh, mistake. Integers. All right, let's see if that would do it. I need to return. So when you're doing these callables, this callable, when you're doing this lambda expression, it's actually calling a method called call that's in this callable object. So you need to return a string for that method. So once you get down here, just go ahead and so you add that right here inside of this callable. You return this done. All right. And forget the interrupted exception. Just do an exception. That should do it. Ran into an error here. I figured out what the problem was. When we're doing this, it's not guaranteed that this chunk size is going to come out as an even number. So if the numbers aren't even, then there's going to be a remainder, and there's going to be some of the indexes that aren't reached. So what we're going to have to do is handle the remainder that's left. So what I'm going to do is a quick and dirty way. I'm just going to have this remainder, variable here, and it's going to tell us how many integers are left after we do this chunk calculation. So I'm going to use the modulus, and then I'm going to do pool size. All right, so this should give us what's left over. This remainder is what's left over. So if the length of the integers array is not divisible by 3, there's going to be a remainder. So I'm going to get that remainder, and I'm just going to append that to the last sublist that we're doing. So in order to do this, we're going to go if we're going to need to check if this is the last is this the last sublist that we're doing. So because I want to append it to the last one. The other ones are going to be the regular chunk size. This one's going to be larger than the other chunk sizes because of the fact that we have to add the remainders on. So once I check to see if this is the last sublist, then I want to check also if the remainder is greater I mean, if the remainder is not equal to 0. Probably should say if it's greater than 0. Yeah, let's do that. If the remainder is greater than 0, then we'll do this. So inside of here, we just want to add the remainder object. So we're going to loop through. We already have I established, so I'm going to do J, and we're going to start at the starting point. Plus chunk. And then we're going to go to the end of the integer array. All right, so we're going to start at the last index of the integer array, and then we're going to go all the way to the end of the full integer array. All right, so then we're going to take those last couple off of the end of the array and add them to the sublist. So once we do that, this should include the rest of the missing integers from here, so we wouldn't get this. See, this is the max value, which means that we just didn't find this to set it. So that means that we were missing some. So let's try that. All right, so as we can see, we passed all the tests. Let's try to run the real thing. So down here, we're going to do attempt. Let's see if we can get it. All right, we got it. So this solution did work. So we're going to go through and see what other people have. I'm curious to see what other people did to get this completed. All right, let's see. Well, this is really clever. People are really good with these streams. So let's see. We only need the first 3 integers to determine whether or not we're chasing odds or evens. That's what I said. So we take the first 3 integers, compute the value of math absolute on each of them. It will be 0 for even numbers, 1 for odd numbers. Now add them. If the sum is 0 or 1, then we are chasing odds. If the sum is 2 or 3, then we are chasing evens. That's clever. See, so he did it in parallel. Like, so his way was pretty much what we did, just way less code. Call it parallel to get much bang for your buck on a large array. And then he filtered mod, find the first. There, see, okay, so that was really clever. Let's see what else we got here. Odd count, even count. So he's looping through the integers. Okay, so that was pretty simple. So these guys got these streams, man, they're really useful. I don't use them as much as I should, but they're really good. They're really nice. So here's just a couple of them. So that's it. Thanks for watching. I'll see you guys in the next video.